Hello, everyone. Thank you for joining us for this timely discussion on geospatial intelligence, new data to solutions, which we are recording and will be rebroadcast a couple of hours after we finish at Space News and on YouTube. I'm Space News correspondent Deborah Werner, and I'm delighted to speak with experts on this subject. Scott Curry, Black Sky Vice President of Geospatial Solutions, who previously spent about 20 years in the intelligence community. Brian Pope, Maxar Intelligence Vice President of Intel Programs, who's worked for Maxar and its predecessors for a couple of decades, supporting the defense and intelligence community. And Chad Anderson, founder and CEO of Space Capital, a seed stage venture capital firm specializing in space-based technologies and applications. As you can see, we have a great panel. Before we begin the conversation, I want to thank our sponsor, Black Sky, and show a brief video. In recent years, defense and intelligence community leaders have emphasized the importance of commercial geospatial intelligence to complement government capabilities. They've noted that commercial data can be shared with allies and the public, helping to show, for example, Russian preparation to invade Ukraine in 2022, and it's revealed subsequent events from wars to natural disasters around the world. Commercial data sets also can offer unprecedented temporal or spatial resolution. The Trump administration's proposed 2026 budget calls for significantly reducing funding for commercial geospatial satellite intelligence programs, including electro-optical commercial layer, EOCL, a $4 billion 10-year program launched in 2022 to buy high-resolution commercial imagery, and commercial synthetic aperture radar, a similar program for radar data that was expected to begin this year. These proposed budget cuts are part of the Trump administration's broad campaign to reduce federal spending. At the recent GeoInt symposium, it was striking to hear defense and intelligence leaders continue to emphasize the importance of commercial imagery and data. As we've reported in Space News, industry and congressional leaders are working to restore funding to these programs. It's unclear what will happen, but it's a good time to talk about commercial geospatial products and services. Brian, can you start us off telling us why they're important?
Sure. Thanks, Deborah, and thanks for Space News for hosting us. Appreciate the opportunity here. For us, I think, geospatial data and products and services are definitely in line with the Trump administration and how they're directing USG to more aggressively embrace commercial partners. And so first and foremost, I think we're all aligned on the directors that are happening. For us, broad applicability of geospatial data and products and services is really key. Our data, the data in the commercial world, is used to serve many different missions, from foundation mapping to site monitoring solutions to AI/ML programs and systems and capabilities, safety of navigation, and to fill intelligence gaps. It also provides a source of truth and observation for our consumers. So broad applicability is number one. Number two, there are a broad set of USG mission use cases, from training to mission planning to navigation, disaster relief, force protection, crisis response, intelligence analysis. And that's what makes geospatial data products and services so important to the community. And then lastly is the shareability. We hear a lot about the need to share this information and data with our partner nations. And so commercial certainly gives us that mechanism to do that. Coupled with the scale of data and kind of what we're facing, how we apply techniques to exploit our data and deliver for the mission is critical. Stop there. Thanks.
That's great. Thanks. So, Scott, Why does the government need commercial data products and services if it has its own satellites and data products?
Hey, thanks, Deborah. So look, the U.S. government has built satellites, high quality that deliver high quality classified data at enormously high price points for many, many years, right? For explicit government applications. And commercial capabilities, as Brian said, complement these government capabilities by offering, if you look at our new generation of satellites with both Maxar and Black Sky, the quality level is about 80% of what the government has now at a far lower price point than what the U.S. government is paying for their bespoke system. So I think one of the advantages that commercial is by generating and enabling more competition, we can push the envelope faster to a more competitive price point for future national systems as new systems are on-ramped into various tranches. But I think what we provide that Brian mentioned was our access to be shared by government for border protection services, natural disasters, coalition forces sharing, etc. But I think what's kind of surprising to me is, as you mentioned earlier on the Trump administrations and their desire, the executive orders, the Pentagon's 2024 commercial space integration strategy, and the slogans for buy what you can, build what you must. It seems to me that this is the Trump administration, in the words they're saying, is putting commercial in a position where they can be more competitive and bring down cost and find more cost efficiency, whereas the actual actions that were taken on the budget proposal seem to be at odds with that. And that's what has us a little bit concerned right now. But I will tell you, after having been in the intelligence community for 20 plus years, this isn't the first time it's happened. We've negotiated these before. There's always competition for budget dollars between commercial and national systems. And so we're all kind of organized in such a way as to negotiate a settlement that works for everybody. But there's a lot of work ahead of us to get there. Over.
Yes. Yes. And so, Chad, why do companies need government customers? And do they need a stable government customer that continues a 10-year program for, say, 10 years?
Yeah, we're in a big transitionary period right now. So historically, government has been the primary, if not the sole customer of Earth observation and remote sensing data. That is changing, similar to what happened with GPS when it was a purely government capability built by the government for the government. And then companies like Trimble came in and developed commercial GPS receivers that basically abstracted away the complexity and allowed any enterprise, consumer, any business to basically access this really valuable positioning data from orbit. Earth observation is going through a similar transition now through players like Skywatch. They are aggregating data from a lot of different players, making that data very easily accessible through an API, and allowing new customers to access this really valuable data set for the first time, which is growing the pie. So Earth observation, remote sensing and geospatial intelligence are both multi-billion-dollar markets today. Most of that has been driven by government demand, and like the way that you kicked off this webinar, talking about conflict areas and things like that, driving increased demand. Certainly, there's been a lot more interest in getting access to the insights and intelligence that's coming off of these orbital assets. But we have a growing opportunity in terms of commercial sales and enterprise sales. So the government contracts continue to be really important. The government continues to be the largest buyer of this data and this information, even though the commercial market is growing pretty rapidly. It's starting from a small base, right? So, yeah, I mean, having access to the government as a customer who places an order and then follows through and and purchases that data that they promised is really important to a lot of these companies while the commercial demand is developing.
So now let's turn to the pace of innovation in the commercial sector, because it's actually hard to keep up with as a reporter. The new constellations, the new data products, it seems to be moving very rapidly. Black Sky, for example, continues to update its Earth observation constellation. Scott, what is the latest there in terms of your satellites and products?
So yeah, thanks. So the last several years, we operated on a system we called Gen 2, which was 80 centimeters at best. Really, bulk of it was about 1 meter resolution. And we had developed analytic AI ML products that detected and to some extent characterized objects at a particular site, which was a great start for us. We are now entering a new era with our new Gen 3 constellation. We have 2 vehicles in operation today, getting ready to allow that general access to those by various customers as we continue calibrating those assets. But that will allow us to get to 35 centimeters in quality, and the plan is to have 6 of those launched by the end of this calendar year, with 12 at the end of 2026. So we're moving at pace, and much of that is based on U.S. government requirements that were awarded to us under EOCL. So as Chad mentioned, the stability of those government contracts is key because we use that to purchase long lead items like telescopes, star trackers, etc., to build out that constellation and to schedule launch windows and contracts with various launch providers. So that system has become operational today. It's growing, and we're doing some testing with the U.S. government to double check and make sure and verify the accuracy and quality of that data. We also talked about a new wide area collector system called AROS that we've been designing for about 2 years now. It is a wide area collector. It will complement our point target collection system we call Gen 3. So it's not a Gen 4 design, it's actually a complement and will give us more capacity and more flexibility in satisfying both wide area and point target monitoring requirements, both of which we are continue to develop analytics for further detection and characterization of smaller and smaller objects that can be detected with these higher quality images. So it's not just the U.S. government, though. As mentioned earlier, we have a multitude of international governments that are also on contract to access this data. And that's one of the additional reasons that I think commercial is so important to the U.S. government is these international contracts offset some of the development costs of these satellite constellations. So the U.S. government gets an even better price point as those costs are shared amongst various international governments. Over.
Before I turn to Brian, will you just tell us, Scott, why wide area collection is important?
Well, I think in our opinion, there's going to be a significant loss in capacity in that area over the next several years. A lot of those assets have been in operation well beyond their design life. So we think internationally and within the U.S. government and at the direction of the U.S. government, they want some additional competition in that area. So we've been working on a design in an effort to access more revenue and more opportunities on the international side as well as on the U.S. government side.
Yeah, that's interesting because for so long we focused on, looking at one site what is happening at this one site. And now I understand there's demand to look at a country and
Yeah, you can
see.
use that and look at that country and do some change detection that would tip and queue then additional accesses by your point target collection system, right? Either tipping and queuing your own assets, or when Chad talked about integration with other sensors through APIs, you could tip and queue other assets and other constellations as well. So it does offer a greater opportunity for kind of monitoring purposes across the globe.
Mhm. Great, thank you. So Brian, Maxar announced a new modern monitoring product today called Sentry. What can you tell us about that and any other updates?
Yeah, sure. Thanks. First, I'll echo some of Scott's comments and Chad's. Like Scott with Black Sky, we are also responding to the needs of the government. Today we have six satellites, 6 additional for Worldview Legion satellites, high resolution. And again, it is in response to the market. But to echo Chad's comment, we are seeing an uptick in the international market space right now. The international market space is there's a trade-off now. Do they need to have more of their own capability? How much can they rely on the US government for sharing in those types of purposes? And so I think there's a sea change happening in the international market around the international countries adopting their own capabilities, and they're looking to commercial to accelerate that. And we're seeing a lot of that today. And so I think that echoes some of Scott's and Chad's comments. As far as the pace of innovation, I think for us, I would open that it's really important to have a two-way dialogue with the customer. There's no doubt that industry can go quickly. We've proven that we can do it. The question is, are we building the right things? And that's really the fundamental question that comes down to. And so it's incumbent on us to engage industry, to understand their requirements and needs and build solutions. But it's also incumbent on the government to speak up and talk about their problems and the challenges they're facing through industry days, presentations, dialogues. And it's a good thing we're seeing more and more of that. And so if we're going to invest our dollars from an industry perspective, we want to make sure we're putting it towards the right thing. Then you mentioned Sentry. Yes, we rolled that product out today. That is our persistent monitoring solution to really drive strategic operational threat intelligence at a global scale and help solve that problem. The one thing I think for us is interesting about Sentry is it's not just getting another data provider. It's about a combination of tasking through our virtual orchestration, virtual collection system. And so it's really important to be able to orchestrate your virtual constellation effectively to maximize what you're collecting, when you're collecting it, and where you're collecting it with what sensor. There's a component to Sentry that's about production, that's really about how do we pull in that data and co-register it, make it highly accurate, that it helps feed then the AI/ML systems that we want to do analytics on, and to object detection and third-party data and bring it in to solve problems for our customers. And so the components of Sentry, just, a lot of people look at an object that's detected. There's so much more that goes into that to be able to deliver that effectively. And so back to my previous point, how did Sentry come about? Well, we won a delivery order through NGA's Luno contract, commercial analytics contract, which helped to really inform us on the requirements and needs. And so we kind of worked with NGA. We were delivering for that, which was delivering within hours of image acquisition to detect aircraft, ships, vehicles, rail cars, to do that site monitoring as you talked about. But a lot of what we did for NGA informed us on what type of product to build, what do customers actually want, and we were able to rapidly create the Sentry sort of system and product in order to ensure that we're building the thing that will meet the market and has broader utility. And for us, that's a little bit more about Sentry. In terms of pace operations, we're also doing that in other capacities. We have a product that we've iterated on quickly. That's our Raptor product suite, and that provides next generation GPS resilience using our 3D data. And again, we're seeing a gap in the market. We're talking to customers and we're responding, and we're able to do that quickly. Over.
Chad, any thoughts on the pace of commercial innovation? I think you're muted.
Thank you. I think it's interesting to think about what's happened over the last decade or so and sort of put into context how things are accelerating. So we have, we had very exquisite, very few government systems up, prior to SpaceX. By removing the barriers to entry and allowing new entrants to come in, we are now seeing a level of innovation that we've never seen before. We have a different variety of sensors that are going up, right? We have optical, we have radar. We've talked about a bunch of these things today. Hyperspectral, we've got infrared, we've got various, we have a variety of sensors that are gathering an unprecedented amount of data from orbit across all different types of sensor types, revisit rates, accuracy in terms of resolution, accuracy in terms of just quality and positioning. And you combine that with the decades of archival information that we have, right? And the real challenge today is deriving useful insights and information from this overwhelming amount of data. And the only way to do that really is to run it through an AI system, because it's just too much information for humans to comb through and parse through and to derive insights from. So there was all of this, I touched on it earlier, but there was all this already happening with companies like Skywatch that are accessing, aggregating information, providing access through an API, structuring the data, making sure that it's accurate and that it lines up and that it's in the correct place, right? And then you can overlay different types of data sets, right? All of that sort of important plumbing was already in the works, right? That was already happening, and it was unlocking access to this, really valuable data for a whole host of new customers. That was already happening. And then we had this, the open AI ChatGPT moment of basically AI becoming ubiquitous in everything that we do in a very short period of time, right? Well, that is just accelerating the innovation and the growth that we're seeing here. It's been touched on a couple of times in a couple of the responses, but this is, for us as Space Capital, this is probably one of the biggest areas of opportunity in the space economy today, is this intersection of geospatial intelligence, of which, Earth observation, remote sensing is a piece, this geospatial intelligence and the intersection of that and AI. Geo AI is a huge area of opportunity. And it's one of the fastest growing areas. If you look at where the investment dollars are going in the private markets, we're seeing growth in geospatial intelligence, Earth observation applications growing faster than almost any other area, right? So this is a place where we're spending a lot of time thinking about, where we are not just thinking and talking about it, we're also putting our money where our mouth is and investing in companies in this space. We are interested in, geospatial foundation models. The current foundation models that exist that are based primarily on text are not really suitable for this. So getting the right embeddings and making sure that the location intelligence is embedded in the information is really important. And then also, to layer in on top of this, as we move into this AI-powered world, synthetic data has emerged as an essential tool for accessing this information and driving insights. So there are many reasons why real data is not sufficient to train AI. One, we've basically gone through all of the information that exists in the world. So we ran out of that. We exhausted that very quickly. Also, there's lots of situations in which the situation you're looking to detect hasn't happened yet. You might need more than just one sort of image or one angle one scene to train your AI. You might want to take that same scene and train it through a multitude of different angles and like lighting situations and things like that. There's lots of reasons why real data is insufficient to train AI algorithms. So that's really where, you know, another company in our portfolio, Rendered AI, comes in, where they help to generate synthetic data, physics-based synthetic data to train your AI algorithms. And this helps Earth observation remote sensing companies in a number of ways. One of which is if you have a new sensor and you want to launch a new satellite, it allows you to synthetically generate the imagery that you expect to get from that satellite, which allows you to, one, train your AI ahead of time. So instead of like launching your satellite, waiting to commission it, getting the data down, getting a critical mass of data to train your AI, you can now do that in advance, which really shortens the time for you to take that sensor to market. But it also allows you to go out and have conversations with customers well in advance of even launching the satellite, right? You can go to them and show them the type of data that you can get and how that can benefit their business. So synthetic data has emerged as an essential tool for AI and also business development in this AI-powered world.
Yeah. So Scott, what thoughts do you have on AI and its importance in this sector?
No, I think they've, Chad and Brian spoke about it very well. I think AI is the future. There's no doubt about it. I think we have one government customer in particular that would like to transition from consuming pixels to consuming only the analytic output of the data and never look at an image. Because they know it's going to be overwhelming. They do not have the thousands and thousands of analysts that the U.S. government has at NGA to look at this. So they are really, really interested in doing that. They are, and others are investing in workflows and infrastructure that can take advantage of that. I think one of the things that concerns me a little bit on the U.S. side is, you know, you've got to put some effort into helping mature these algorithms to build the confidence that the output of that algorithm is satisfactory. And I'm talking about, when I say satisfactory, high, you know, plus above 90% probability, right? On these F1 scores, et cetera. So I think culturally, this is going to be a big challenge for a lot of customers. But I think the recognition that we've all talked about here is the output and the use of analytic workflows and tools is going to be critical to people making best use of all this data that Chad talked about, from RF sensors, from SAR, from hyperspectral, from EO, et cetera, and making sense of it in a very complicated and fast-moving world. There's no way you can have enough analysts to do this manually. You can't do it today, much less than 10 years from now, at the rate of change and the pace at which we're expected to put up more and more collection systems into space. And I'm going to offer that's really just the terrestrial part of this. And when you talk about looking up and the space domain awareness into deep space and other things, you know, those are whole new areas. What is the conjunction of geospatial data with non-Earth imaging, with Golden Dome activities, et cetera? I don't think we even know yet, right? There's just a lot of opportunity there, and probably can't predict 25% of what might happen here over the next several years.
Very true. Brian, anything to add there?
Yeah, I think Chad and Scott covered a lot well there. You know, for me, you know, we've been in the AML world here for 10 years here at Maxar for our imagery, and it's been an evolution, and it's a journey, and that hasn't stopped and will continue. And so Scott said it's the future. I'd say it's the now, and it's part of the past. It's never been. We've always been thinking about it and trying to advance what we're doing. a lot of things that originally you would see, basic object detection, right? Detecting cars, planes, trains, those types of things. From high resolution imagery, we see analysts, they want more fidelity. They want to know more about it. They want more context to what you're identifying. We've seen AI ML in feature extraction, buildings and roads, and that are updating maps real time, after a certain event, whether it's a natural disaster or otherwise. And how do you do that efficiently and effectively? And then to Chad's point, we've been in the synthetic game for a while, and how do you apply synthetics into the world to advance the number of labels you have, the number of different scenarios? It's super complex, as Chad said, right? You can look at one of our sensors at a certain off-nadir angle that collects at a certain season, and that needs a different model than a different sensor at another season at a different angle. And it gets really complex. And then, of course, Chad commented a little bit on the next generation of models. And, we're seeing a lot of the multimodal integration of large language models with imagery. And so ultimately, an analyst wants to see an image and says, tell me what's happening here. What am I looking at? And the contextual information is provided through AI. And it's a journey in my mind. And we're trying to take advantage of the latest technology. But to Scott's point, you have to get it right. And I think there's when we talk about the challenges and the opportunities with our customers, it's about how do they trust what we're doing and what we're finding? And how do they integrate that into the workflow? And that's a wholly different problem, or a challenge, or an opportunity in and of itself. So I'll stop there. Thanks.
Scott, how does the U.S. regulatory environment help or hinder U.S. commercial innovation and competition, because this is a very international market?
So we're even before the recent cuts that DOGE levied on NOAA, it was a cumbersome and time-consuming process to navigate your way through that. We have a single-band SWIR capability on our Gen 3 constellation that we're still working with NOAA and the various working groups to figure out how we can share that beyond the U.S. government. That's probably going to take another year to resolve itself, right? That's how slow these things are. So they're risk averse. The U.S. government regulatory system over the years and continues to force us to look at what are the capabilities available in the international marketplace today. And are we exceeding any of that, right? And if we're exceeding any of that, then it requires additional scrutiny, right, before it's released. So in my opinion, over the last several years, the regulatory environment for the U.S. has always ensured that commercial was a second mover compared to its international competitors, which is super frustrating, right? As we're going through this, we were hoping and continue to hope that the Trump administration would fix that. We certainly have a lot of discussion with those on the transition team from the Biden to the Trump administration and raise those concerns. I'm hopeful that we see some results from that here over the next year or so. But right now, it's a difficult thing to navigate. We're okay on the EO side primarily. I think the one that's probably the most at risk right now is those vendors that are producing very low on the VLEO marketplace, right? Where they've got, 10 centimeter licenses, and they've probably got tier 3 licenses for that. So they'll be scrutinizing what can be discerned from that kind of data once it becomes available. Again, I would expect that to take a long time before they're able to resell any of that outside of the United States government. Over.
Brian, turning to you, what are some of the challenges in providing the government with solutions rather than simply data?
Yeah, I touched on this a little bit in the answer to my previous questions. There are challenges, and we also see those as opportunities. And I come from a world where I supported the U.S. government, DoD, and the IC, and sort of in those spaces, so I've seen it sort of firsthand. For me, number one is workflow integration. So if you provide something, how does it integrate into an existing workflow? And where is that workflow? It could be on different networks, on different systems. And so, we need to figure out how what we provide can integrate into these workflows. I think latency and speed of delivery is always a question for the US government. Like, how quickly can you get that to me? And how can you deliver that solution to meet my requirements from a timeliness perspective? I touched on this previously. When we're applying AI and ML or doing producing solutions, there's a big element to trust in that. And from a commercial perspective inside the US government, how do you implement that? And so educating our customers of how the things work and what we're doing and showing them and demonstrating is a key component to adoption. And that's a critical element. We also look at formats and specs that are standardized, how those can be easily integrated. And that's a lot done oftentimes in partnership with the government of like, how do you define the spec and what should be produced? I think Scott touched on a little bit with the models in and of themselves from an AI sort of assurance perspective. And then lastly, in my experience, what we produce commercially off the shelf rarely is the 100% solution. It always takes some element of integration and configuration to meet the needs. And I think a lot of times you think you can buy something and it's plug and play, but there's oftentimes an iterative process to understand with the government what we need to do to tweak our solutions to meet the need. And so that's always a challenge and oftentimes takes many iterations and some time to figure out. Over.
I see we have a lot of questions in the chat. If anybody else has a question, feel free to drop it there. But before we get to those, Chad, does the investment community understand this market? I thought of that when Brian mentioned education of customers. Are you educating investors about what's here?
Yeah, so just to kind of like take a half step back too and pick up on what Brian was saying, because I think it's really interesting about like, it's actually what I was hearing Brian say is actually not so much educating customers, but actually meeting the customers where they are, which I think is such an important piece of this, because when geospatial information is successful, you don't notice it. It's like GPS. Again, like I'm going to keep drawing these parallels because they're super important, but I mean, because they make so much sense, I think. But the value and like the power in GPS is that it operates in the background and it's so invisible, like you hardly even give it credit for what it's doing, which is basically powering everything in your life, right? And geospatial intelligence is going that same route. But in order to meet the customer where they are, it's about abstracting away that complexity and making it super simple so that it feeds directly into their work stream that exists, right? Like insurance. We all know insurance is a big customer of geospatial information. Like the State Farm person is going to go and they're not going to go and log into, Earth Observation Company website and like download imagery. And, like the future of this is where that insurance underwriter goes and sits at their desk and they log into their intranet and they just do their job underwriting policies. Maybe they don't have to get out of the office as much. Maybe that data is piped straight into what they're doing. It's going to enhance what they're doing in ways, and help them to be more efficient and more effective in ways that they couldn't do before. But it's not like that's the value and the power here. So, and I think, just to put like a fine point on this, Rendered, the synthetic data company that I talked about earlier, they just released this enhancement to their product where you can actually go and tell it in natural language what it is you're looking for, and it will produce photo quality images in an infinite number of scenarios, right, to give you the training data that you need. You can say, I want to see, this type of ship out at sea in these types of conditions, and it will generate those images for you. Like, so again, all of this is like compounding the innovation that we were talking about earlier. Is the easier that we make this for people to just use the tools that they have, which are, not necessarily like a data science team, that's been trained on all this stuff, but like when you can use your natural language and your natural smarts to leverage this information, that's what grows the pie. So I just wanted to say that before I address your question. But on the investor side, no, I don't think. I think that actually, and it's not unique to space, but in sort of or geospatial, but like in any area in which things are so dynamic and happening so fast. Again, we've been operating in space for decades. We've had Earth observation satellites in orbit for decades, but the amount of innovation that's happened in the last 10 years and last 5 years, and even, it's speeding up. So over just the last few years, there's so much happening, and it's so dynamic that it's really difficult to understand the nuance and the complexities of what's going on here and to keep up. We spend, we have a whole team doing this full time, and we have a hard time keeping up with it, right? So I think that investors, along with governments and other stakeholders, are awakening to the importance of this of space technology generally, but of geospatial intelligence as well. Waking up to the fact that it is essential for our economic stability and growth and national security, and we are making resources available to prioritize these assets, the protection of these assets, to ensure that we can continue to get this really valuable data from orbit. And as we do that, more people are getting smarter and educating themselves. We've been, I founded Space Capital 12 years ago, 13 years ago now. And so we've been through this evolution along with the space economy, right? And so very early on, it took a lot of education to help people understand the opportunity, the real risks, and to see that there was money to be made here, there was opportunity here, right? So we did a lot of internal research that we then used to help educate investors and help people get smarter about what was going on. Today, the market needs a lot less education than it did back then, so it's all relative. This is a really hot category. Like I said, there's kind of an awakening happening where people are paying attention to what's going on here. But research is still a core piece of what we do at Space Capital, so we continue to do a lot of research and publish that research to help people understand the breadth of the opportunity, because it's not just about the satellites and the infrastructure that's in orbit. It's about how you're using that infrastructure. What are people actually doing with it, right? So those are that comes from the research and the frameworks that we've developed. We published the GeoInt playbook along with a number of other playbooks to sort of help people understand this. And so it's all relative. It's much less education needed today. Yeah.
Got it. Let's bring in Dan Robitsky, the Space News editor, to ask some questions from the audience.
Sure. Thanks, Deborah, and thanks everyone who asked questions. We certainly can't get to all of them, but I think a lot of the ones were actually already answered by the webinar, so that was great. I want to start with a quick question actually from Space News senior staff writer Sandra Irwin, who wanted to ask Scott what the projected timeline is for Black Sky to achieve 60-minute revisit rate with its high-resolution constellation.
Yeah, thanks for the question, Sandra. So because we launch our satellites into mid-inclined orbits anywhere from 59 to about 35 degrees, depending on where you are in the latitude belt, it requires about 12 satellites to achieve 60-minute revisit, which right now, budget issues notwithstanding, we would achieve that in Q4 of 2026. We have our on contract with NRO requires us to deliver more than that. But that now we're going to have to see how that plays out in relation to how the budget in 2026 plays out. But right now, the baseline plan is to have 12 up in the end of 2026 calendar year. Over.
Great, thank you. We also got a number of related questions, and some of them were about future markets for geospatial intelligence. So I'll ask a question by James Wooten, who asked, what other industries other than defense do you anticipate will become major consumers of geospatial intelligence, especially GeoAI? Other questions specifically asked if there was additional growth in other civil use cases or climate use cases, things like that. So curious what your predictions are.
I'm happy to chime in on that one to start. I think the answer to my question is there already are use cases that we're serving beyond the U.S. government. And so an example, and I'll touch on Chad's point, my guess is that some of the users on this call used our data and the commercial data without ever knowing they used our data. If you went to a navigation app to go somewhere today, that data was likely produced from commercial imagery. And that is a result of what Chad says. You may never see that. You may see the result of the data. And so to that point, when you talk about updated maps and features for autonomous vehicles, for autonomous drones, that is needed from an accuracy perspective and from how they're going to navigate the globe. And so there are other emerging markets, and we're seeing things because having accuracy in space and knowing where you need to be and accuracy in terms of the features that are there are not only vital for U.S. government missions, but they're critical for other missions that we're solving today.
Yeah, and this is a fun question, so I'll jump in too. But I'll quote Skywatch CEO James Sleafers. He says, "We're getting to a point where a non-technical user inside a Fortune 500 company can query satellite data as easily as they can use Excel." And I think that is what's so interesting here is that we are, there is an infinite number of use cases for this data. It's basically, again, drawing a parallel to GPS. I mean, if you think about GPS satellites in the beginning, like how are people going to use this thing? Those questions were asked, in panels at space conferences in the 70s where, it's great. You got this positioning information, like how are people going to use this? And it's hard to answer that question because you're like, everyone is going to use this for everything, right? And so it's really hard to sort of like nail things down, but we're starting to, as we unlock access to this information, we're starting to get a sense for who will use this. And it's across basically every major industry here on Earth, right? Agriculture, insurance, maritime, logistics, shipping, any kind of remote operations, construction, real estate, and all of those industries are leveraging this data more and more as it becomes more accessible. We're seeing a few like sort of specific examples are around the integration of data sets. So again, I said in the beginning that Earth observation and remote sensing is one input to geospatial information systems. By combining that with UAVs, ground, and other sensors, you start to get this really interesting and robust data set that will answer any question that the customer has, which unlocks way more use cases than one data type can solve. And then another fun one is really around 3D. So we are moving into a 3D world. Like we think very much in terms of like 2D, and when we think about geospatial information, it's very much like in terms of 2D, but the world has moved on to 3D, and we're kind of where 2D was 15 years ago. And so the future is going to be very 3D, and that enables all kinds of things like spatially accurate digital twins and some other really interesting use cases. So I could go on and on about that, but on this question, it's a fun one, but those are kind of the big ones.
Yeah, thank you. I mean, I think you're right that a lot of people are just not aware how ubiquitous a lot of this already is. I'm going to change directions for one more. So Jay Motor, and I apologize if I butcher your name, asks, how is the industry working together to ensure that variety in sensor types, persistence, time of collection, and spectral diversity is meeting the evolving operational demands of both government and commercial users? And I would add, is the industry working together to do that?
I'm happy to jump in here too.
Fire away.
Okay. Well, I think that it's happening out of necessity. It's not like a coordinated activity where everyone is like sitting down at a conference table and shaking hands and saying that this is something that we should do. I think that, again, if you get out of you know, if you only focus on the infrastructure, like that's kind of the worldview that you would have. That's the data supply. But if you start thinking about things in terms of the market demand, the end users who are actually buying this data, especially the new use cases, the people who haven't used it before, like the big opening of the aperture, the market that is growing, those customers don't care where the information came from, what sensor type it is, what company built, built the satellite, who's operating the satellite, how many satellites there are, what the revisit is. They don't care. What they have is a business question and they'd like an answer to. And so they want to be able to ask the question and through an API call, get the information that they want from wherever is, whatever data supplier is best positioned to provide that information to answer that question at the right price point, at the right frequency and whatever else, the right accuracy, the right quality of data. As long as you meet all of those, all of that, and it flows right into their work stream, like they're very happy with wherever it came from, right? So in that way, this platform, sorry, I'm mentioning this so many times, but I think it's just such an important piece of the puzzle. It's bringing the Earth observation and geospatial worlds together and growing the pie is by bringing these different data types together through a platform like Skywatch that is enabling the end user to get what they want in a way that they want, which is again going back to the point of meeting the customers where they are.
I think I'll add to that. I think the market's interesting. In some cases, we're competitors and we're trying to win market share, but in a lot of cases, we're not. And we realize though that what is good for one is usually good for all. I mean, we're trying to grow the market, and companies like, you can't afford to build every sensor of every satellite of every type. You have to look for the partner to augment your capability, and how you're going to integrate that together to deliver for the customer ends up being critical. So to Chad's point, is there direct, hey, you build that satellite, I'll build that satellite? No, but there's definitely a dialogue and a discussion around the market in general and how we're competitive in some cases, but complementary in others. And I think that's okay. And that's how the business works. And, Scott and I, we see each other, we talk all the time, it's okay. And but we're understanding how we want to grow the industry as well. And, our leadership talks all the time, and we're advocating collectively for the growth of the commercial space market.
Yeah, I think when I came in from government, one of the things that's been most interesting to me was, as much as I'd like to have Black Sky build everything, right? You can't make a business case for that. So you're right. How do we partner? We were, for instance, we were saturating the U.S.-Mexico border with our constellation over about a month, about a 2-week period. Then we tried it again with a SAR partner. Wow, much better, right? And so the combination of those things together is really helpful, I think, for a SAR provider to have an EO complement company helps people understand that data. I think to me, when I had to deal with SAR data on my own in the government, it was hard to really come to answer all the essential elements of information with a SAR image. Much easier if you had a complementary EO image to kind of guide you on to exactly what this is. So, we've all been looked at business cases for hyperspectral. What is the global revenue opportunity of hyperspectral, and which bands are the ones that the U.S. government wants versus another company? What is the resolution level of that band that it needs to be built to be viable? There's just a ton of questions out there. They all cost money. Launch costs have gone down, but they're not insignificant. And there's a lot of technology involved in that. So yeah, these are all myriad of questions that we deal with week to week. And even Brian and I, as he mentioned, talk about partnership opportunities at times because we try not to overlap each other if it doesn't make sense, right? So anyway, it's all, yeah, we're doing everything Chad said we're doing, but we're doing it kind of sometimes onesie twosie and sometimes as maybe a triad of RF and EO and SAR together makes sense sometimes, and we tried that as well. So, but there's no company I don't think that's going to ever be able to do it all, which is probably not a bad thing.
Great. Well, thank you, everyone, and thank you, everyone in the audience, for asking questions. If we had another half hour, I'd love to ask a few more, but since we are nearing the end of our time, I want to hand the reins back to Deborah for any more questions and thoughts.
Thanks, Dan. Thank you to my panelists for an informative conversation. Is there anything else any of you want to say as we close out this conversation?
I'll just
No,
say thanks to Deborah and thanks to Space News. It was an enjoyable conversation. And as Dan said, we could probably go on for another hour easily. So thanks. We'll need to do it again.
Yeah, and appreciate all the questions. They cover the waterfront for sure. We would need at least that much time. Thank you.
Yeah, good to be here. Thanks very much.
Yes, we tend to have a very well-informed audience. And as I mentioned, this conversation has been recorded and it will be available in a couple of hours at spacenews.com and on YouTube. Thank you to the audience for thought-provoking questions. And thank you to Black Sky for sponsoring today's webinar on geospatial intelligence. So, okay. Bye, everyone.